Hello my dear students, welcome to the class. In this math simplified session, we'll talk about a very important concept that many times gets overlooked, right? And I know that you must have felt the same way, that either in the class the time has been less given to this, but it's actually very interesting. And the point of this particular session, this particular small session in this topic, Argand Plane, is that whenever you're dealing with a question of higher level in any competitive examination based upon complex numbers, you should be able to visualize the question, how it is flowing. Okay, that's why I have brought this session in your math simplified series. So let's look at this particular concept in a very simple way. But before we start, do not forget to hit the like button if you are somebody who were thinking, okay, yes, this session will make certainly my understanding of complex numbers easier. Okay, so do not forget to hit the like button and share this video with all of your friends who are studying in first PUC or second PUC and needs a quick revision of this particular topic. Let us start right now. So of course, topic is very simple, so we'll just quickly understand or revise what is the complex number, and then we'll move on to the Argand Plane side only. Okay. Achha, by the way, I hope you all have checked out, right? So I have released the entire one-shot lecture of this chapter complex number in the first PUC one-shot series. Correct? So every Saturday the session is coming, one-shot sessions for mathematics, and again it's for coming for other subjects as well on different days. You have to go and check the playlist on our home or basically in our channel Deeksha Karnataka. Okay, but let me tell you, every Saturday one-shot lecture comes in the first PUC chapters. And every Tuesday we have one-shot lectures for second PUC chapters. So I have done a one-shot lecture in the complex number. It will be very helpful if you are thinking to revise this, whether you are a second PUC student or if you are somebody who is already in first PUC and wants to recollect the memories that you recently learned in your class. Okay, because first PUC started long back, right? So you might have, if you should revise it, there is the way to revise it, because I've covered so many questions from NCERT, MCQs, subjective, MCQs for competitive style, so all has been covered over there. Just take my suggestion, go and check it out once. Okay, what you can do, if you ask me my suggestion how to use it, sir, I will recommend you go to our AIO page, download the class notes, refer it, and then go back to the session and watch those parts. Okay, because this is going to be a long lecture, close to 3 hours, 2.5 hours, 3 hours, so it might take longer for you to learn the whole thing. But let's say you want to learn only certain part of it. Got it? What you can do is simply go to our AIO page. What is AIO page, beta? It's all in one page, okay, where we are teaching you all for free. What you get? You get all the YouTube lectures over here. Okay, you get class notes, you get quizzes, you get assignments, doubt solving, all is available for free. How to access that? Yeah, the question is of course very fair. How to access that, sir? If something that wonderful is there, how to access that? And is it there for only second PUC or first PUC also? Is there for both second PUC as well as first PUC student. Now what you need to do is simply click on the link provided in this video description as free ACE KCET 2027 series. Okay, you will find the link. I'll repeat the name: free ACE KCET 2027 course. Click on that link, register yourself, again free of cost, no charges, start learning right away. Okay, so this is clear what to do, how to use the one shot. Let's get back to the session at hand. This is the standard form of complex number, which is where A represents your real part and B represents your imaginary part, right? The I is the symbol for representation, right? So I is nothing but the iota. How do we get that? Remember, in the quadratic, when you're finding the root of negative numbers, we can't find that. Root of -4, we can't say it is -2, can we? No. Root of -4 is written as root of I square into 4, because I square value is -1. So we write -4 as -1 into 4, and then take basically this I'm talking about. Okay, let me change the ink color. Yeah, will be more visible if I take something different. 1 second here. Yeah, so if I take root of -4 now, what is the answer going to be? You write this as -1 into 4. And this is going to be what? I square and 4. That becomes I times of 2. You write this as I2 or 2I, your choice. Okay, that represents the imaginary part. Great guys, A is real, B is imaginary, nothing else is over there. So let's not waste our time on this slide. Moving on. As I mentioned, the session is about visualizing the complex number with the help of Argand plane. So let's just do that today. So Argand plane represents, again, very similar to what you've learned in your Cartesian planes, right? XY axis, very similar. So that's why, many questions, or in the higher level of competitive examination, you'll find which will relate towards coordinate geometry in the complex number as well, because the axis is very much similar. The x-axis here is called as real axis, because complex number has two parts, right? Complex number has two parts. If I write a complex number z equals to x plus iy, then x represents the real part, so that will be represented on the real axis, and the y value is represented on the imaginary or vertical axis. Okay, so let's look at some examples. If omega or w is a complex number, then this is on minus 2 plus I. It means this over here and this over here. Minus 2 is on the real axis and I is on the imaginary axis. Basically I into 1, or you can write it as I also. So over here you can see 3 plus 2i. The value 3 is on the real axis and 2i represents on the y-axis. Again, sign convention also remains same as what you've learned in the basically Cartesian plane xy axis, right? Here plus plus, here you can see minus plus. Here you'll have both minus minus. For example, I want to write this number, let's say. Okay, this number. You'll have, you'll have minus 2 and minus 2i. Minus 2 represents this negative real value and minus 2i is the negative imaginary value, and so on. You can write in the fourth quadrant as x positive, which is real number axis positive, and the imaginary axis negative. Very similar, nothing else is there. Okay, y is imaginary, x is the real axis. Every complex number that you see, every complex number represents a point in the Argand plane. It represents a point in the Argand plane, and named after Jean Robert Argand, 1806. Okay, how do you plot it? So very simple, we did it over there only. Identify the real part, identify the imaginary part, and look for that quadrant, right? Here you'll have both plus plus, here you have minus plus, minus minus, and plus minus. But that of course you guys know, so I'll not spend much time over here. Okay, accordingly whatever number given to you, let's say I have 2 plus 3i, so x is also positive, y is also positive. It means real part as well as the imaginary part, both positive. So the value, the complex number will lie in your first quadrant. Okay, yeah. Next, something called as modulus. What is modulus? Of course it represents absolute value. This represents absolute value, just the magnitude. Sometimes we also call this as just the magnitude, correct? Just the magnitude makes sense. But if you relate with Argand plane, mod of z means distance of that particular complex number from the origin. Complex number represents a point, right? Yes. So if I am talking about, let's say this point, which is what? A plus IB, let's say this is the coordinates AB. Then this is my complex number, A plus IB, and it represents, the mod of Z represents this line. Excuse me, yeah. It represents this line, which is from the origin, okay? And how do you find this value? If I say, please find the distance OA, find the distance OA. Can you use distance formula? Distance formula, grade 10 you've learned, right? Yes. So if you use distance formula, you'll write A minus 0, so A square, and B minus 0, the whole square becomes B square. Check carefully, that is same for the formula of modulus. So modulus represents, the modulus of any complex number represents the distance of that point, which is represented by the complex number from the origin. What if, sir, you have mod of z1 minus mod of z2? Mod of z1 minus z2. So z1 will represent one complex number, z2 will represent another complex number, right? And this difference will represent distance between these 2 points. Clear? Yes, so this is the same understanding. 3 plus 4i is given as the complex number, then root of 3 square plus 4 square becomes root of 25. Answer is 5. And since it is a distance, it will always be positive, even if you have on a negative side of the axis. Argument. Argument means the angle. Since we are learning this, right? This is the complex number, sir. Excuse me. Right? This is a complex number, sir. Let's say a comma b. Then argument means the complex numbers line, this line that joins the origin and the point, makes with the positive real axis. Positive real axis. Okay, so this is the argument. And how do you find it? So of course, if you plot this triangle, let's say this is OAB, you know this value represents B, this represents A, because this is on the imaginary side, this is on the real side. So write this as tan theta as B by A. Theta becomes tan inverse of B by A. And one more thing very important, you always take this as tan inverse of modulus of B by A. So you find the modulus of B by A, and later we can simply use the rules for each of the quadrants. Okay, here will be same. Let's say this value. So actually instead of writing theta, we can simply write this as alpha, let's say, because theta is the argument, right? So this is not the final value, this is the alpha. In this you'll have theta as alpha, theta as minus alpha, here theta as pi minus alpha, and here theta as minus pi plus alpha. What's the meaning of this? As per the quadrant where the complex number is located, because it is a point, you will have the argument defined in these 4 ways. Okay, so you find the alpha value. How do you find alpha value? Tan inverse of, take modulus of B and A. Just keep it simple. Take modulus of the value which is given, because usually it will be negative also, right? If it is in the 3rd quadrant, or let's say 2nd, or let's say 4th, okay, then you'll have some negative values. So take the modulus, find that particular value of alpha. If the value is in the 1st quadrant, if the point lies in the 1st quadrant, that alpha is same as theta. If it is the 4th quadrant, that is minus alpha. 2nd is pi minus alpha, and the 3rd quadrant is minus pi plus alpha. Okay guys, so example you can see over here, 1 plus I root 3, this will be in which quadrant? Over here, this is going to be 1 comma root 3. So answer becomes tan root 3 by 1, that is going to be 60 degrees or pi by 3. I hope this is clear. Angle made by the line OP, which is the line joining the origin and the complex number, with the positive x-axis, a positive real axis. Clear? And of course measured anti-clockwise, that you know how to measure the angle part. So argument is important. This keeps coming in your papers. Okay, very relevant to all of you. Next, the polar form of complex numbers. Okay, so this is also very relevant, very useful, and we do have this concept since we learnt about theta now, and this we learnt about this as well. The R represents mod of Z. Can you find this? Please try. Write mod of Z. You write this mod of Z as root of A square plus B square. Okay, and if you check over here, you'll have. Can you say this? If you multiply with this and this, you'll have R cos and R sin. Right now, if I compare this with A plus IB, then your A value becomes here given R cos and R sin. So if you apply formula of A and B in the modulus, what is the formula? Please check. A square plus B square in the root, right? You'll have R square cos square, R square sin square. Take R square common, you'll have cos square plus sin square, that becomes 1, and the root of R square will become back to R. Okay, this is clear. All right, so great guys. This is again direction component, which is the case of unit vector, because obvious the R value is 1 in this case. R value is 1 in this case. Okay, we do have Euler's form also, but not in the syllabus of CET or your boards. That's why I have not taken that part. Complex conjugate, how to represent that on the number line? So if you have a complex number, let's say Z as 2 plus 2i, then this is nothing but Z bar. That is a symbol for conjugate. You know that very well. If you don't know, go ahead and check it out. My one-shot lectures on first PUC, complex numbers and quadratic equation. I have covered everything over there in detail. Okay, go and check it out. Okay, so if I ask you, what is the argument of this? What are you gonna say? So this is the, let's say, theta. And what about the argument of this? This value will be how much? Minus theta. So the question like this also comes. Sometimes people ask this, argument of z plus argument of z bar is equals to what? Remember, this is always 0. Argument of z plus argument of z bar is always 0. Does not matter which quadrant. Always 0. Okay? I've taken one example to show you. And if you multiply them, z into z bar, you'll end up with mod of z the whole square. Mod of z the whole square. Yes. Yeah. And of course, this looks same. This is the mirror reflection. Check here, 2 plus 2i. 2 minus 2i means across the x-axis, y is changing sign from plus 2 to minus 2. Plus 2 to minus 2. Yeah. Adding the complex number. This is very important, right? Adding algebraically is this a plus c and b plus d. A plus c and b plus d, that's what we do. Add the real and imaginary part. What about in the case of Argand plane? So first step is to join this line. This will represent mod of z1. This will be what? Mod of z2. Form the parallelogram. This will be mod of basically from here. Same, no? Z2 only. This will become mod of again z1 only, right? This will be same as this because remember, this is a parallelogram. Okay, this is a parallelogram. Correct? And what happens in parallelogram? The resultant using this law, this sum is what? Is this diagonal? Is this diagonal? This represents your value z1 plus z2 mod. z1 plus z2 mod. Can you see this happening? Yes. So if this is the second complex number, the first one, the sum is equivalent to, you draw the parallelogram using the given 2 points, the given 2 complex numbers, and a diagonal of that will be simply your sum as per the Argand plane. Okay. So as it's mentioned over here also, plot z1 and z2 as vectors from the origin, complete the parallelogram. The diagonal will represent the modulus of z1 plus z2. And this is the triangle inequality where sum of basically any one side will be. So if you look at this triangle, let's say, this is what z2, this is what z1 only, right? So this 2 is different sides, this is the third side. So any one side will be what? Either less than or equal to the sum of two other sides of a triangle. That's why it's called as triangle inequality. Remember this. If you draw a triangle ABC, a triangle, one second guys. Yeah, one second, just a second. ABC, we know that C will be less than or equal to A plus B, or we can write in any different way as well, but point is simple. Any one side will be always lesser than or maximum equal to, in the case of, when will this be equal? When it becomes a straight line, okay? C is equals to AB when it is. A, B, C are collinear in nature. The points are collinear in nature, but it doesn't matter that right now, but C will be, any one side will be always less than the sum of other two sides of the triangle. That's your triangle inequality, equal when it becomes collinear. Okay, that's all guys. So quadrants, let's just talk about that. I've already given the angles of different quadrant. In this, both of them are positive in the first quadrant. Here we have the negative real axis in the second quadrant, negative real axis. In the third we have both negative, real and imaginary. In the fourth we have only imaginary axis negative. Clear? Same as XYZ plane. Okay, just reference. Okay, have a look. Complex number, its modulus, its conjugate, its argument, polar form, and this result of product of complex number and its conjugate. Okay, and some questions to practice. Just review this once. What is this? Very simple ones. If the complex number given, find the modulus. We'll use the formula, right? If you have to find the conjugate, just change the sign of this. Do not change the sign of -2. That's very important. In conjugate, sign of imaginary axis changes. Does not change sign of real axis. In which quadrant does this will lie? This will lie in the third quadrant because both of them are negative. So third quadrant. Express this in the polar form. Again, r will be equal to root of a square plus b square. So 1 plus 1. That becomes root 2, and theta we can find using argument. Okay, theta is the argument. Clear? Common mistakes that people make. Yes, confusing the real and imaginary axis. always remember x is real and y is imaginary. If you want to have a reference, remember this. We had different forms of quadratic equation. In quadratic, we had three conditions. When d is equal to 0, this was the touching the x-axis. When d is more than 0, we had cutting the x-axis. We had cutting the x-axis at 2 points because 2 roots. But when d is less than 0, the graph, if you remember, was above the x-axis. There is no real value because it does not touch the real axis, only above. You can remember like this if you want to. Okay, so always remember x is real, y is imaginary, because in this case the roots are imaginary, right? If d value is negative means roots are imaginary, and it does not touch x-axis means x must be real. Okay, forgetting the negative sign for conjugate. Conjugate means negative only for b, not for b. Sign change or sign flips for only b, not a. Wrong quadrant for argument angle. Be careful with that, and I've given you different way to find the angles in different 4 quadrants. Use that. Okay, and taking the modulus wrong. This is very common, very rare, but sometime it can happen. So that is all about this session, where I talked about your Argand plane. How do we utilize this in our question solving of competitive? Very useful. It helps us visualize a lot better. Okay, and do not forget to check out the session, the one-shot session that has been given for the first PUC series. Check it out, learn from there. Anything else you want me to improve in any of the classes, let me know in the comment section. That is all in this class. I'll see you the next time. Till then, take care. Bye-bye. All the best.